Hey guys, we're Team GFORCE 19013 and we're going to take you through downloading Android Studio, the FTC SDK, and take you through your first op modes. Also note that we've included a coding guide with codes, links, explanations, and more. First, visit the Android Studio website. You can Google it or refer to the link in our coding guide. From there, you can download the Android Studio installer. But first, you're going to have to accept the terms and conditions. Once you've accepted the terms and conditions, launch the launcher and give it administrator access. Go through the installer as we show and wait for the app to install. After it's done downloading, visit the GitHub repository for the FTC SDK. The link for this website is also in the coding guide. From there, use the HTTPS link from the GitHub repository to import it into Android Studio. If you don't have Git downloaded, click the button to download Git. Then, click the clone button. You can click Trust this project, as the repository is made by First Tech Challenge itself. After you've downloaded the SDK, be sure to wait for all the Gradles to be built. Now, on your left-hand panel, navigate to the team code folder and expand Java under that. Then, right-click on the org.firstinspires.ftc.teamcode folder, select New, and then Java class. For the name, you can enter Hello World. Now, we'll make our first op mode. An op mode is a program for the robot. A robot can have multiple op modes, which are all stored in the team code package. Next, after public class Hello World, add extends op mode. This makes our new class, Hello World, inherit from the op mode class, which is part of the FTC SDK. This provides methods like init and loop that we can use to define our robot's behavior. Now, above the public class Hello World, add @teleop. This is an annotation making sure the name of the op mode shows up as teleop. Then, after the class declaration, add @override to override the functionalities of the parent class, meaning this method is callable from outside the class. Then create a new method using public void init. The init method is what runs when you start the program, allowing this method to start immediately. Finally, add telemetry.addData hello world with hello world in quotations, separated by commas. This sends the data hello world back to the driver hub, thus essentially sending a message. This same concept can be used later on to find values such as velocity, acceleration, and for debugging while the robot is running, just by using telemetry to pass the relevant data to the driver station. Finally, create a new method with @override, which performs the same function as before, and then declaring a new method using public void loop. This method would loop all the code inside of it. However, we are not including any code inside of it because we don't need anything to run. However, it is necessary to finish the program, so we've included it. Now, let's create a new op mode to take input from our gamepads. We're going to start by making a new Java class in the same way as the previous one. Right-clicking org.firstinspires.ftc.teamcode, selecting New, and then Java class. You can keep the name something like gamepad op mode. Now, let's talk about the gamepads themselves. Since there are two of them, they're called Gamepad 1 and Gamepad 2. The buttons on the side of the gamepad are Boolean, as in if they are pressed true and if they're not pressed, false. The joysticks are double values between 1 and -1, with 0 being the center. There's one side for X and Y. X is negative to the left and positive to the right, and for some reason, Y is negative up and positive down. The left and right triggers are also doubles between 0 and 1. Now, let's make our op mode. After public class gamepad op mode, add extends op mode, as we did before. Then, add the annotation @teleop, so that it shows up on the driver station as so. Then, once again, we can create the method for initialization with @override and public void init. However, this time we will put no code in it since we don't want any code to be run at initialization. Instead, this time we'll use the loop method. Again, create the method with @override, then public void loop. This time we want the code to constantly be executed so that we can always listen for inputs from the gamepad. To get information from the gamepad, we can use variable name.member_name. The diagram currently on the screen shows all the member names for all the buttons, triggers, sticks, etc. on the gamepad. Now, add telemetry.addData and in brackets, in quotes, left stick X, so that it is a string, comma, gamepad.leftStickX. Similarly, do the same thing for the Y stick. Now, add telemetry.addData, A button in quotes, then comma, gamepad1.a. Now, we've added functionality for the gamepad's current inputs to be displayed on the driver station. This could be used, for example, when testing if a gamepad works. Now, let's make a new op mode to implement a tank drive system, that is where each side of the robot is controlled by a joystick. Once again, let's make a new Java class by right-clicking org.firstinspires.ftc.theme code, going to New and Java class. You can keep the name something like tank drive. Once again, after public class tank drive, add extends op mode and add the @teleop annotation before the class declaration. Then, using the class DC motor, we can declare the motor objects by adding private DC motor left motor and private DC motor right motor. Then, again, we'll create our init method with @override and public void init. Now, we'll initialize the hardware variables. To the variable left motor, assign hardwaremap.get in brackets dcmotor.class, the string left motor, and then close the brackets. Do the same for the right motor. Please note that the names of the strings, such as left motor and right motor, must correspond to the names in the robot configuration file on the driver station. Let's also set the motor directions of the objects we just defined. This is important because by default, some motors may spin in opposite directions when given the same power. To correct this, one motor is usually assigned an opposite direction, which can be done by leftmotor.setDirection in brackets dcmotor.direction.reverse. The opposite can be done for the right motor, that is rightmotor.setDirection in brackets dcmotor.direction.forward. Note that reverse and forward must be in all caps. Let's also add telemetry.addData status :initialized so that the user of the driver station can observe what state the robot is in. Now let's create our loop method. Add the @override tag and add public void loop. Now inside the loop, we want to take input from the gamepad to assign a certain power to each motor. We can do this by adding double left power equals negative gamepad1.leftStickY. And to do the same for right power, we can do double right power equals negative gamepad1.rightStickY. Then we just set the motor power to the variables we just defined. So left motor.setPower in brackets left power and right motor.setPower in brackets right power. Finally, we can add telemetry data for debugging. Just add telemetry.addData in brackets a string left power, comma, left power, the variable. Then do the same for the right. Telemetry.addData in brackets the string right power, comma, right power. Congratulations, you've made your first op modes. After this tutorial, you're now able to add telemetries to the driver station, accept input from the gamepads, and control the motors on your robot. Good luck and happy coding!